Okay, the last section of chapter 5 is called inverse of a function. This is the last section of chapter 5. Inverse of a function. And you know what? Totally gonna ignore this because I think that's confusing. Okay. We're gonna start right here. We're gonna start with the equation. Maybe we'll look at this just for a second. I changed my mind. I'm sorry. I'm like indecisive right now. All right, so let's start here. And it says solve y equals f of x for x. So we're going to take this and we're just going to solve it for x. That's the part I'm not going to do. Okay. What I'm going to do instead is I'm just going to find the input when the output is -7. What that means is plug in -7 for y. Or f of x is -7. So in this equation, I'm going to put -7 equals 2x plus 3. Now, what would I have to do to solve that for x? Because normally we solve for y. What would I do to, well, if I normally put something in an equation, I would solve it for y. So this one, I already know y. I kind of need to go backwards to solve for x. So what am I going to do to both sides? Jackson, what am I going to do? Subtract 3. Good. After we subtract 3, then we will do what? Say something out loud, please. Divide by 2. And I would have an answer. Okay, but what we really did was we subtracted 3, we divided by 2. That's what we did. We subtracted 3 divided by 2. This part we're ignoring. Okay, so the original question in that example that we were just looking at was y equals 2x plus 3. If I plugged something in for x here, let's say I plugged in 10 for x, I would first multiply by 2, and then I would add 3. But since I plugged something in the other side of the equation, we plugged in, what did we plug in? I already forgot. 7, -7. We plugged it in the other side of the equation. We subtracted 3, and then we divided by 2. So what we're doing is we're doing opposite operations, which are called inverse operations in the reverse order. When you plug something into one side, or if you plug it in the other, you're doing inverse operations in the reverse order. Let me say that again. If you plug something into 2x plus 3, you multiply by 2, then add 3. But if we plug it into the other side, we plug it into the y value, which they've already kind of rearranged it, so you just plug in y right here. If you plug it into the y value, you're first going to subtract 3, then divide by 2. What we have are two equations that are called inverse functions. Oops, going too fast. If the steps undo each other and they're in the reverse order, then they're called inverse functions. The two functions to each other are inverse. They completely undo each other. So what they did was they took these two equations, they made one of them f of x equals 2x plus 3, and then they made the other one subtract 3, then divide by 2. They made that into a function, g of x. You see how whatever number I put here, I subtract 3, then I divide by 2. So it's the inverse operation. It's going to be called an inverse function. Now, when we make inverse functions, we switch all the roles of x and y. We switch all the roles of x and y. We switch all the x's and y's. When we have inverse functions, we're going to switch x and y. And that's going to affect the domain and range as well, because those have to do with x and y. And we'll see all this with an actual example. So here is in blue, the original function we were just talking about, 2x plus 3. Here's a table of values and a blue graph of 2x plus 3 of all the values for 2x plus 3. And then in red, we made an inverse function where if we do the opposite operations in the reverse order, the table of values, if you compare the red ones and the blue ones together, all the x's and y's are completely switched. Do you see how -2, -1, and -1, -2, these are totally switched? 0, 3, 3, 0. You see they're just switched. X and y's are switched. When we graph the red points, they are symmetric with the blue ones. But the line of symmetry is the y equals x line. That was really messy. I'm going to try writing that word again. The line of symmetry is the line we called y equals x. And that's the line where we have ordered pairs like 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. So when you switch the x and the y values, the graphs become symmetric to each other. And they're always symmetric over this same line, y equals x. So that's what we're kind of saying when we're doing inverse functions, is the y is the x and the x is the y. So that paragraph, I just summarized that. So we are going to find the inverse, and this is what we're doing today. We're finding inverses of functions. That's what we're doing today. We're going to go through the steps of finding the inverse. So the first thing that you need to do is we need to make it say y equals. So take out f of x. Replace with y. So I've got y equals 3x minus 1. Now we can do the equation first, or we can do the graphing first. That does not matter. We can do the equation first, or we can do the graphing first. That does not matter. I'm going to go over to the graph. Let's just get this guy graphed, okay? Before I start, since I know that I'm doing inverses, like that's the title of this section, I'm going to put in a dashed line. Wait, can I put in a dashed line on here? Anybody know? Can we do a dashed line? Maybe not. Maybe I'll just put in a yellow line. I couldn't figure out how to put in a dashed line. And it's going to go from the bottom corner to the top corner. And that line is the y equals x line. And I put it light colored because that's not my answer at all. But this is going to help me check to see if I'm doing things correctly, or maybe find my answer. So remember when we graph lines, so I'm going to graph y equals 3x minus 1. When we graph lines, we can find the y-intercept, which if you plug in 0, we get -1. Plot that. And then for lines, we use our slope value. So our slope is 3, which is the same thing as 3 over 1. So from our y-intercept, we go up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then since you guys are using your computers, you do have ways of making lines on here that are simple. Okay. So I haven't done anything about an inverse yet. All I've done is write y equals instead of f of x equals and graph that line. That's all I've done. So I haven't done any of the new stuff yet. This is stuff that we did the first week of school. Okay. And in Algebra 1. So now I'm going to actually start with the inverse. Okay, here's a big step. This is step number 2. It's a big step. Step 2, we're going to switch x and y. Here we go. I'm going to do it. I'm going to have the inverse. Here we go. X equals 3y minus 1. That is the inverse. We've found the inverse. It was a hard one, huh? Should I do it again in slow-mo? All I did was switch x and y. This is the inverse. So now we don't leave it like this because if it's a line, we are going to graph it. So we want it to be like y equals form. So our step 3, oopsies. Our step 3 is solve for y. And there is a step 4, just so you know when you get to that place there. So we're going to solve this equation for y. So the first thing I'm going to do is add the 1. And then divide by 3. So our original equation was multiply by 3, subtract 1. For this, I just added 1 divided by 3. So it's complete opposite operations in reverse order. And then step 4 for finding the inverse. If the inverse is a function, put it back into function notation. So function notation is that f of x instead of y. But here's a special symbol that you might see that means this is the inverse. Instead of just f of x, it's going to have a special symbol on that f. It looks like an exponent. It is not an exponent, but it looks like an exponent. It stands for inverse. I don't know why I did this in blue. I meant to do it in pink. So we've got a special little -1 towards the top. It stands for inverse. And I get x plus 1 over 3. Now, if you do not like your lines written in that form, you could write your form like 1/3 x plus 1/3. So you could divide both the x and the 1 by 3 if you want to write it in that form instead. Either form is totally acceptable. Either of those is fine. Now we have to graph it. So you have two options when it comes to graphing. You can either A, look at this line here, find the y-intercept, graph it at 1/3, then use your slope up 1 over 3. Or you can use what we learned about inverses right up here, which I'm going to use. Whoops, went too far. Right here. All the ordered pairs are just switched. So if I graphed my first line, all I have to do is take any of the ordered pairs on the purple line and switch the x and the y. So instead of 3, 8, and I just labeled that so I wouldn't have to count it later. Instead of 3, 8, I'm going to graph 8, 3. Instead of 2, 5, I'm going to graph 5, 2. Instead of 1, 2, I'm graphing 2, 1. Now, it is a line, so I could use my slope from here. It's up 1 over 3 or down 1 back 3, and I could just keep going. Or I could just use my straight edge and finish my line. The purple and the pink line should look like they are symmetric with that yellow line. They should look like a reflection in the y equals x line. If it doesn't, then you're probably wrong. Okay. So let's practice a couple of these maybe together and then try one on our own. If you want to work ahead of me and just see that you're understanding and doing it right, that's totally fine. I'm going to start with number 4, and I'm going to put in my yellow line first. And I'll just put in my yellow line for all 3 of them. My y equals x line, just so I have it. For each of those. And my first equation is y equals 2x. So I begin at 0 and I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. When I go to do the inverse, I switch my x and my y's. So for the inverse, I get x equals 2y. So that's my inverse step. Just switch x and y's, and then we're going to solve it for y. I'll have to divide both sides by 2. And then finally, I write it as a function. And I wrote it 2 different ways. Either is totally fine with me. So now to find the equation, to find the graph, we can either graph the equation 1/2 x, or we can just switch all of our ordered pairs for the original equation. So 0, 0, if I switch that, it's still 0, 0. If I switch 1, 2, it's now 2, 1. If I switch 2, 4, it's now 4, 2. 3, 6 is now 6, 3. And then draw a line. Sometimes these are like really easy to find the inverse operation if you just think about what you're doing, and you don't have to do it this way. I feel like I'm not as good at what I'm about to do. If I put something in for x, if I put some value in for x here, to solve for x, I would have to, gosh, come on, work. There. To solve for x, I'm sorry, to solve for y. If I put something in for x, I would have to first multiply by -1, and then I would have to add 1. So my inverse should be subtract 1, divide by -1. That's what my inverse should be. So if you're good at this, you could potentially say x minus 1 divided by -1 would be my inverse. If you can do it this way, that's great. I'm not so good at that. Did I lose anyone on that one, or? Because I can do it by hand too. I'm just showing you there is a little bit of a shortcut. And if I simplify this one, this is the equation I get. Does anybody notice anything weird about this one? Anything that you notice and wonder about for number 5? Number 5 has something interesting. Anybody notice and wonder? Holland, you see anything weird with number 5? Not yet. Do you see something weird, Sophie? No? All right, well, let me graph the original equation. I'll graph it in blue. Start at +1 on the y, and then our slope is down 1 over 1. So down 1 right, down 1 right, down 1 right, down 1 right, down 1 right. Okay, and then I'm going to switch my ordered pairs. So if I switch the ordered pair 1, 0, I get 0, 1. If I switch the ordered pair 2, -1, I get negative 1, 2. If I switch the ordered pair 3, negative 2, I get negative 2, 3. If I switch the ordered pair 1, 2, 3, 4, 1, 2, 3, 4, negative 3, I get negative 3, 4. Does anybody notice anything about this one yet? Ryan? They're exactly the same. And that's because that line has symmetry over the y equals x line already. So they are exactly the same equation because they already has symmetry in that y equals x line. Okay, one more. I'll do this one the long way. Let's see. I'll graph it first. I'm going to begin at negative 2 on the y-axis. Then I'm going to go up 1 over 3. And that was y equals 1/3 x minus 2. So we have to find the inverse. So I'm going to switch my x and my y. So I have x equals 1/3 y minus 2. So I switched my x and my y. So now I'm going to add 2. And then I'm going to multiply by 3. And then I'm going to write it in function notation. So again, the one in blue, to the x, we would basically divide by 3 and then subtract 2. The one in pink, I multiply by 3 and I add 6. That does not sound like it's opposite, does it? And that's because I had to simplify. So right here is really where it sounds opposite. So my original, I had to divide by 3, subtract 2. My new one, I'm multiplying by 3, or I'm sorry, I'm adding 2, then I multiply by 3. But because I simplified it, that's why there's a 6 in there now. Okay, and then for graphing, we can either just look at the pink one and graph it, or we can look at the blue one and just switch ordered pairs. Either should work. That was bad. What's up? Of the original? 1/3. Of the blue one? 1/3. How do we find the slope, Sophie, for number 6? Or is that what you don't remember? So it's the m value. It's the number that's multiplied by x. That's our slope. And then the b value is the y-intercept. All right, the last part we're going to do today is non-linear inverses. And here we have a blue, which is y equals x squared, or f of x equals x squared. And then the red is its inverse. Then we have a blue, and this was a little harder to see, so it's a good thing it's in color. We have a blue cube, x cubed, and then in red, the cube root. Those are inverses of each other. They undo each other. Cubed and cube root undo each other. Squared and square root undo each other. Right? Square and squared root, they undo each other. They're inverses. There's just one thing. When we have a function, it passes a vertical line test. So if I take any vertical line, that one's kind of hard to see. Let me do a different color. Take any vertical line. If it is a function, I can take that vertical line anywhere, left to right. If it's a function, it will only cross through my vertical line at one point at a time. So this blue y equals x squared only passes through once. But what about the inverse? How many times does this vertical line pass through right now? How many times does my vertical line cross with the red graph? Anybody? 2. You see where it crosses 2? Then say 2. This red graph is not a function because it fails this vertical line test. Over here, the red graph passes the vertical line test. If I go side to side, the blue graph also passes the vertical line test. But the red graph fails the vertical line test. So what happens if it's not a function? Then you can't put it in function notation. If it's not a function, when you're done, you know how I was writing it like that when we were done? If it's not a function, you can't do that. If it's not a function, you can't write f to the -1 of x. You just put y equals if it's done when you're done. That's all. That's it. That's the difference. It's the notation. Okay? All right, let's find the inverse of a quadratic or cubic function. It says quadratic. I forget to change this every year. This is cubic. Every year I forget to change that. Okay. So we're going to find the inverse of a cubic function. And then we're going to graph the function and its inverse. And you know what? I'm going to start with the graphing piece. So we have cube root. And this is what we were doing earlier. I think it was section 5.3. We were doing graphing. So for the cube root graphing, I'm going to use x's that are -8, -1, 0, 1, and 8. And when we take the cube root, -2, -1, 0, 1, and 2. And then we're going to look at transformations. We've got a -4 and it's underneath the cube root. Is that horizontal or vertical? If it's underneath the cube root, is that horizontal or vertical? Not everybody at once. Ella. Is this 4 horizontal or vertical? It's under the cube root. It's inside the function. Horizontal. So do I do -4 if it's horizontal? What do I do? +4. And we do it to the x side. Remember, everything horizontal is opposite. Okay, then we've got this -2. It is not under the cube root. It is not under. Aya, is that going to be horizontal or vertical? Vertical? Do I do -2 or do I do +2 for vertical? I couldn't hear you. I do -2 because vertical, we don't change the signs. We don't change the signs. We do -2. So you keep the sign the same. So this graph is going to be at -4, -4, 3, -3, 4, -2, 5, -1, and then 12 off the graph, 0. Bless you. Okay, that is the original question. Now we're going to find its inverse and we're going to graph its inverse. We're going to find the inverse and we're going to graph the inverse. So to find the inverse, remember first I make this y equals, and then I switch my x and my y. So I'm going to have x equals cube root y -4 and then subtract 2. So there's our inverse. And then we have to solve for y. So I'm going to add 2, x plus 2 equals cube root y -4. So this is what we were doing. In 5-4, we were solving. So if I'm trying to get y by itself, how do I get rid of the cube root? Cube. We do its inverse operation. So I have x plus 2 cubed equals y -4. And then I'm going to add that 4. And I will have x plus 2 cubed plus 4. So add the 4 to both sides. If it is a function, we're going to put it in function notation. And here's a hint for you right here. What color do I want to write it in? I'll put it in black. Okay, if it's an odd degree, when you find the inverse will be a function every single time. If it's an odd degree. Here we're talking about cubic, that's odd. So it will be an inverse. So I will write my answer in inverse notation. No, function notation. Sorry, said the wrong thing. It will be a function. Write it in function notation. And that will be my inverse. So I can graph that by making another table and doing all my transformations on another table. Or I already have the ordered pairs in the first table. What could I do to my ordered pairs to graph the new one? Just switch them. So I'm going to graph -4, -4 is the same. I'm going to graph -3, 3 instead. So I'm just switching my x's and my y's. -3, 3. I'm graphing -2, 4. I'm graphing -1, 5. And I'm graphing 0, 12. And if you turn the graph, or you turn your head and you look at that line, that yellow line, these two graphs should look like they are symmetric, like they could fold on that yellow line and all the points would match up. Okay, let's just do one last one together. We're going to consider the function f of x equals 2x squared plus 1. Determine whether the inverse f is a function, then find its inverse. I'm going to do it opposite. I'm just going to find the inverse first and graph it. And then we'll talk about if it's a function or not. We'll do that kind of last. Okay, so I'm going to start with graphing the original question. The original question is squared, quadratic. I'm going to make a table of my x squared values. So I'm going to start with -3, -2, -1, 0, 1, 2, 3, and I'm going to square all of those. This right now, I'm doing fast because it's from chapter 2 and chapter 3 over and over and over again. We did this a lot in chapter 2 and chapter 3, and it was a while ago. And then the transformations on that, we've got a 2. The 2 is not being squared. Tessa, is the 2 horizontal or vertical? It is vertical, so we do not change the 2. We just multiply everything on the vertical side by 2. And then we've got a +1. And that +1 is not being squared. Emma, is the +1 horizontal or vertical? Yes. If it's being squared, it's horizontal. Then it's vertical, right? Anything horizontal, the parent function, whatever the parent function, it's happening to it. So like on this one, the parent function was cubic. So anything underneath that cube root is horizontal. Here it's quadratic. So anything being raised to the second power will be horizontal and nothing's being raised to the second power except for the x. You guys see how Emma just asked a question because she didn't understand something? This is what you need to do when you don't understand something, because I can't tell blank eyes with a mask over it if you understand or not. The mask really hinders a lot. Okay, so we're going to add one to our vertical side. I'm not even going to bother with the 18s. That's going to be way off my graph. I mean, you can write it if you want, but I'm not going to. All right, so my ordered pairs that I'm graphing, oops, -2, 9, -1, 3, 0, 1, 1, 3, 2, 9. Remember, quadratics are U-shaped. They're not V-shaped. So round that bottom. Round that bottom. So I did everything with the original. Oh, let me draw one of those yellow lines. Did everything with the original. And now we're going to go talk about the inverse. So to start with the inverse, we're going to switch the x and the y. So I'm going to have x equals 2y squared plus 1. X equals 2y squared plus 1. That's my inverse. And then I'm going to solve that for y. So I'm going to subtract 1. Then I'm going to divide by 2. What do I do next? Ashlyn, what do I do next? I'm going to square root. Now, there is a rule that when I square root, what also do I have to do? Well, I got to put a plus minus in. Very good. So now I have y equals plus minus square root x minus 1 over 2. Oh, and I'm about to get like really, really, really like technical with you. If I've got plus minus a fraction, square root of a fraction, sorry. The plus minus part wasn't important. If I plus minus the square root of a fraction, then I have plus minus the square root of x, what did I put plus? X minus 1 over the square root of 2. Let me zoom in here for a second so you guys can really see it. And a red flag for this chapter has to go off right now. Because what am I not allowed to have? What? I can't have a square root in my denominator. I can't have a square root in the bottom. It's not simplified. So we're going to go ahead and we're going to rationalize that. We're going to multiply by something. And after I multiply by that thing, I will have the square root of something squared so that they'll cancel each other out. Right? Remember, we have to make these cancel each other out. It's going to multiply by a square root that will give me what squared when I'm done? 2 squared. So what should I multiply by that will make this a perfect square over here? Multiply by 2, square root of 2. So if I do square root of 2 times square root of 2, then I get square root of 2 squared, which is 2. On top, I'm going to multiply those. They're both square roots, so we can multiply them underneath. 2 times x minus 1. You can leave it like that, or you can simplify it. It doesn't really matter. You can like distribute the 2 if you want. But the biggest thing is that we got rid of the denominator that had a radical in it. Okay, so we have y by itself. Our last step, is it a function? So I'm going to graph it, and we'll talk about my little trick that I gave you up there that you should already be able to answer if you saw the trick. To graph it, I'm going to just use my table and switch my x's and my y's. So I'm going to have 9, -2, 3, -1. 1, 0. And when I was talking about it being a function or not, I was talking about using a vertical line. How many times does my vertical line cross through my blue graph? More than once? It fails the vertical line test. So not a function. So all that means is when we write our answer that we're not going to write f to the -1 of x. We're just going to write y equals. And what was our answer? Plus minus square root 2 times x minus 1 over 2. So that's going to be our final inverse answer. So that's the only difference between it being a function and not a function is I'm just writing it as y instead of f to the -1x. Okay. And what I had said before, if the power is even, then we're not going to have a function. And this power was even. So it wasn't a function. So it has student practice. I'm not going to do the student practice with you guys. There is a worksheet that goes with this, and that's all it is, what we just did here. Okay? So you've got 8 questions in the book, and then you've got a worksheet of graphing and switching the X's and Y's around. And you guys have 30 minutes before XH.